All right, 2.5, complex zeros. And the fundamental theorem of algebra. All right, so the fundamental theorem of algebra. Says a polynomial function of degree n has n complex zeros, real and non-real. Some of the zeros may be repeated. Then we have the linear factorization theorem. Says if f of x is a polynomial function of degree n greater than 0, then f of x has precisely n linear factors and f of x is equal to a times x minus z1 times x minus z2 times ... x minus zn, where a is the leading coefficient of f of x and z1, z2, ... z to the n, or zn, are the complex zeros of f of x. The z sub I are not necessarily distinct numbers. Some may be repeated. Both of these theorems are existence theorems, meaning that they tell the existence of zeros and linear factors. However, it doesn't tell us how to find them. Then fundamental polynomial connections. In the complex case, the following statements about a polynomial function f are equivalent if k is a complex number. First one, x is equal to k is a solution or a root of the equation f of x is equal to 0. 2, k is a 0 of the function f. And then 3, x minus k is a factor of f of x. And then just a little reminder, if we have I, it's just equal to I squared is equal to -1, I cubed is equal to -I, and I to the 4th is equal to 1. Next we have the complex conjugate. Zeros theorem. So suppose that f of x is a polynomial function with real coefficients if a and b are real numbers with b not equal to 0 and a plus bi is a 0 of f of x, then its complex conjugate a minus bi is also a 0 of f of x. Okay, so if you see one, that means that the other one is also a 0. It won't usually give you both like listed. Quick definition. A quadratic expression with real coefficients but no real zeros is irreducible over the reals. Factors of polynomials. with real coefficients. Every polynomial function with real coefficients can be written as a product of linear factors and irreducible quadratic factors, each with real coefficients. And the last one, polynomial functions of odd degree every polynomial function of odd degree with real coefficients has at least one real zero.